Okay, these are what you need to commit to memory. So every test, there's some stuff you really got to kind of put in your brain and lock it in there, and this is one you have to do, okay? So you have to remember the derivatives of trigonometric functions. So when you see d over dx, what that means, so we're all clear, if you ever see this, that's the same thing as f prime. That's the same thing as saying limit as h goes to 0 of f of x plus h minus f of x all over h. So we're doing that operation to sine. So sine of x plus h minus sine of x all over h. And maybe you remember from last year we had all sorts of sum and difference formulas for trigonometry. Like for example, we said sine of alpha plus or minus beta. And we wrote that as, what is it, sine of alpha, cosine of beta, you know, plus or minus. You remember that? So if you check out your book and you want to see the proof, you sure can. We're not going to go through them all because we're going to do a proof tomorrow that, you know, could blow your mind up. So we're not going to do more than that. But the fact is, if we operate on these, here's what you're going to get. And it's definitely not part of the standards that we show how you get these. They're right in your book. Just trust that it's true. Well, you know what? No. Just watch. Because this is cool. Let's just think of it like this. You don't have to draw this. Just this will be a cool way for you to see it. The graph of sine. What does it look like? Do you know what the derivative of sine is right here? It happens to be exactly 1. What is the derivative of sine right here? 0. Do you know what the derivative of sine right here is? -1. What is the derivative of sine here? What is that the graph of? Cosine. So if we simply drew it out, you would see that the derivative of sine is cosine. Yep. No. The integral of sine dx is actually negative cosine. So. So if we graph those first two out, you would see that if you take the derivative of sine, you get cosine. Derivative of cosine is negative sine. Okay. And the reason why is cosine starts heading down right away, right? Starts at 0 and then heads down. That's why you get a negative value. Okay. And so, you know, that's pretty useful. Now, you can confirm that algebraically, which is what you guys want to see. But you saw a graphical representation, right? And that the first people are looking at derivatives. That's what they looked at. The derivative of tangent is secant squared. Yep, these are facts you got to memorize. I'll prove one of those for you in a little bit, but question? Okay. Actually, find some space and write this down. How can you rewrite tangent? So watch how cool this works. Once you've established sine and cosine as you know, derivatives, the rest are quite easy. I'm going to rewrite tangent as sine over cosine. I'm going to take the derivative. What rule would you use to find that derivative? Starts with a Q. Quotient rule. And the quotient rule says the derivative of the top. What's the derivative of the top? Cosine times the bottom left alone. No, so derivative of the top, cosine times the bottom left alone would be cosine squared. minus the derivative of the bottom times the top left alone all over the bottom squared. So you have cosine squared. So you can see the top gives you 1, the bottom gives you cosine squared, so it's secant squared. So we could verify all the rest of these by simply doing that. Be no big deal. The derivative of cosecant happens to be negative cosecant of x times cotangent of x. The derivative of secant of x is secant of x tangent of x. So again, you are going to have to memorize these for the test. And the derivative of cotangent is negative cosecant squared of x. So you may wonder how I remember these. And the first two you just have to remember, okay? In fact, the first three you just got to remember. Okay? Look at the relationship though, okay? Derivative of sine, derivative of cosine, they're very similar, aren't they? Just one's negative. Well, look at cosecant and secant. One is negative, right? One has a cosecant, one has a secant. One has a cotangent, the other is a tangent. Okay? And then look at secant squared, negative cosecant squared. One is positive, one is negative. They're both squared. So once you can kind of wrestle through that, you could probably come up with a good way to remember it. So once I remember, a couple of these, I could generally remember the others. So let's find the derivative of a few of these. I have f of x is equal to negative 4x plus tangent of x. So if I want to find the derivative, and remember, back in the day we used to do limit as h approaches 0, yada, yada, yada. If I want to do the derivative now, I just have plus secant squared of x. And you're done. Yeah, so Megan asks a very good question. She says, what if I looked at this graph and I looked at this graph? Would I, in fact, tell that one is the derivative of the other? Yes, you sure could. It's definitely a little bit more complicated than looking at the sine and cosine, but you could check. How about this one? Three cosine of x. Well, we'll get to some more difficult ones, so. Okay, so we have 3. Now, you got to be careful after that, everybody. Do you see the problem with this one? Got an x times a cotangent of x. That requires us to use product rule. So you can see this right here. That's the product rule. You have one thing that's a function times another thing that's a function. You have to take those and use the product rule. You can't, use some. We don't have a rule that says what x cotangent of x is. If you have a constant, no, because x by definition changes. It's a variable. Whereas 3 and 4 do not change, so therefore we could just, they just take along for the ride. So we got to do the product rule here. And the product rule says derivative of x is 1. So 1 times cotangent of x. And then I plus x times, what's the derivative of cotangent? Negative cosecant of x squared. And so if you write this out, you end up with f prime of x is equal to 3 plus cotangent of x minus x cosecant squared of x. And that's what we get. How about D? What rule do you want to use for D? No. Exactly. Do that instead, people. If you want to use the quotient rule, go ahead, but you sure don't have to. If you have the opportunity to rewrite something, take that opportunity and do it. So 2 over cosine is just 2 secant. That's easy to find the derivative of. Derivative of 3 is 0, goes away, so I've just got that. Because the 2 is a constant. That'll be like, so as soon as you get confused, always go back to this, you guys. As soon as you get confused, always go back to this. Y equals negative 5 halves x minus 4. That's a line, right? What's the slope of that line? You don't look at this at all, do you? So it's the same idea with the derivative, okay? Derivative is the instantaneous rate of change. The constant does not, by any means, all the constant does is change the location. It's a vertical shift. That's all it is. So we just disregard that. Okay, so back to our notes. How about E? What do you have to do for E? Now you do have to use the quotient rule. So this can take up a little bit of space, but I take the derivative of the top. What's the derivative of the top? Cosine of x times the bottom left alone, which is x plus cosine of x, minus 1 plus sine of x times the derivative of the bottom. Some people started to say that the derivative of the bottom was 1 minus sine squared. Is that correct? Or 1 minus sine, excuse me. All over x plus cosine of x quantity squared. If you could simplify something, you really should do that. Do you notice what happens here? You have 1 plus the sine of x and 1 minus the sine of x. When you multiply that out, what are you going to get? Does everybody see that this turns out to be 1 minus sine squared? Well, 1 minus sine squared is the same as cosine squared. Remember? We just did that yesterday. So that's cosine squared of x. When you distribute this cosine through, you get a cosine of x and a cosine squared, so those will cancel. So you can tell that you're only going to be left with f prime of x is equal to x cosine of x over x plus cosine of x quantity squared. You could, no need. That would be how your book would leave that problem. Any questions? This, cosine of x times x. Cosine of x times cosine of x is cosine squared, which will cancel with that one. X times cosine of x is x cosine of x. Okay, we do 2 more examples. What might you be tempted to do for letter F? Distribute. I'm going to encourage you to not distribute, and this is why. If you distribute, you're going to have to use the product rule twice. So right now we have to use the product rule just once, so let's do that. F prime of x is equal to, what's the derivative of secant? secant of theta tangent of theta times the second part left alone, which is theta plus tangent of theta. Whoop, I always do that. Plus, now I leave the front part alone, secant of theta alone, and I take the derivative of, what's the derivative of theta? 1. It's just like the derivative of x is 1, derivative of theta is 1, plus secant squared. Nope, that's the quotient rule. Product rule says we're done. Nothing in the denominator. Thank you. I'm guessing that your book would probably want to write this in descending order of powers. So I think probably the most typical, not f of x, f of theta, sorry. Oh yeah, I made that mistake up here, didn't I? Ooh, notation. Naughty. No. You can see secant of theta and secant squared will give you secant to the third of theta. You're going to have secant of theta times 1, which would be secant of theta. And then you're going to have secant tan times tan, which is plus secant theta tan square root of theta. And then we have theta, secant theta, tangent theta. So, well, some people might write it with a secant factored out of the whole thing, but, you know, it just depends on how your book decides to leave the answer. The point is that looks pretty nasty, but, you know, we were able to find that derivative relatively quickly, so that's good news for us. One more example before we break for the day, and that's the last one here. Example 2 says, write an equation for a line tangent to 1 minus sine of x at x equals pi over 6. So if you want an equation for a line, what do you have to have? Yep. So we need a point on a line, and we also need slope. Now the point on the line, it says x is pi over 6. Now, you remember from yesterday that if you plug pi over 6 into sine of x, does anybody know what sine of pi over 6 or sine of 30 degrees is? It's 1/2, so 1 minus 1/2 is 1/2. So that's our point on our line. Well, how do we find our slope? Derivative. F prime of x is equal to 1 goes away, cosine. The derivative of sine is The derivative of sine is cosine, right? So do we end up with a positive cosine or a negative cosine? Negative cosine. And so if we want to know the slope, we have to plug in pi over 6. So the slope is negative cosine of pi over 6. And I think if you look at your chart, if you don't want to look at your chart, you can convert them to decimals. That's just fine. But I believe it's negative root of 3 over 2. So now we write our equation. Y equals mx plus b. I'll try to do this without any decimals. If you'd like to convert it to decimal, that's fine. But you'd always need to verify your answer, especially on a test. If there was a multiple choice, one was listed differently. So my point on my line, the y value is 1/2, m is negative root of 3 over 2, x is pi over 6, plus b, right? So I'm trying to solve for the y-intercept. 1/2 is equal to negative pi roots of 3 over 12. Find common denominators. 6 over 12 plus pi roots of 3 over 12 is equal to b. Or 6 plus pi roots of 3 over 12. That's my b value. So the equation for the line is y equals, what's my slope? negative root of 3 over 2 times x plus 6 plus pi roots of 3 over 12. And I know what you guys are wanting to do. You're wanting to see what it looks like graphically, just like I am. So I'm going to plug it in. 1 minus sine of x. Okay, here you go. I'm going to graph it. We're going to see if it's tangent. There's my graph of 1 minus sine of x. And there's my tangent line. Is it cool? Yes, you do. The limit as h approaches 0. We've done it all. Okay, here's your assignment, folks. Okay, 1 through 16, don't do 8 through 10. Sydney, we missed you today. Don't do 8 or 10. Sorry, don't do 8 or 10. Anybody want to say hi to Sid? We did. We just forgot to say it into the video.
What am I saying? I said I miss you. I hope Winona was good.
Sydney, we ate cookies and cookie bars without you. I hate to say nobody realized you weren't here until I finally mentioned it. We did not know Larissa was gone. I remember that.